Hi, this is Abhijit Upadhyay. As per the present curriculum, this time we have done a live project in our department and we are from Department of AC. So our group constituted of 5 members who are Abhijit Upadhyay, B. Dilip Kumar, Supriya Devli, M. B. Vanilla and B. Swati. So we took a project that is Enotice Board for department using LEDs. We have gone for a simple LED panel of 7x64 and then we designed it and implemented in this campus. So this is all about our project that you can see. Here we have implemented 7x64 LEDs, that is 448 LEDs which are connected in a board, and then there is a simple connection in that particular board. As you can see, this is the only board which operates, and this is a place where the output is displayed. In the board, at the back of it, we have used 4 shift resistors, which means each shift resistor is connected to 16 rows of LEDs. So in this way we covered 64 LEDs using 4 shift resistors. So first of all, what happened? The main constituent in this project is there is a display board. At the back of it there are 4 shift resistors, there is a control circuitry. So this shift register will shift each byte of memory, each bit of memory. One bit left shift will be done by the shift register. In this particular board, when we give the power supply, first of all it will ask for the command to input a new message. If suppose there is a message being fed before, then the same will be displayed once we switch it on and we don't give any further input. The control circuitry of this main board consists of a microcontroller, and we have used C89C2051 microcontroller. Along with that, there is a EEPROM extra being connected in this board. The reason of connecting an extra EEPROM is we are having 2 kilobit of memory which can be run in this. But since we are using 448 LEDs, the total memory comes to be around 4 kilobit. So to meet the extra memory demand, we have used this EEPROM, secondary EEPROM. And secondly, this board constitutes the circuitry along with this panel. The main power supply is present in the control room, which consists of a battery eliminator. In this battery eliminator, there is a rectifier and there is a step-down transformer. We are operating it at 3 voltage to get this brightness. So when we give the AC power supply, it is converted to 3 volt using a battery eliminator. Let's come to the control room and see how it is being operated. This is our control room from where messages will be fed to the notice board. So we are using a PS2 keyboard, as you can see, and moreover this is a battery eliminator which is giving the power supply to the display board. Here it has 3 voltage. This battery eliminator consists of a rectifier along with a step-down transformer. This 220 volt is converted down to 3 volt, and as per the required voltage, it is supplied to the display board. So whenever we need to operate, we need to reset it. So for that we have to switch it off and again switch it on. And the process is we have to press E13. E13 is just to it acknowledges. It is acknowledged by the microcontroller to send any input to the display. So once we type E13, then it asks for the command that you type the message that you want to display. Soon after we type the message whatever we want, then just to scroll it down, we press F1 plus F2 plus escape. So this is how a message will be displayed. So let's go for a demo. So here we go for a demo. So here is a keyboard, and whatever we type, it will be coming on the display. As you can see, there is 13, so it is the reset button already being placed. So now, let's go for a message. So now the message has been typed, so we need to scroll it down and see how it is being displayed. So for that we need to press F1, F2 and then S. So this is how our project has simplified the use and display of any message in this institution. So whenever we require to put any kind of notice, depending upon the degree of urgency, we can use it. It's very simple to use, just a keyboard, few buttons need to be pressed and we get the whole display and all the students can access to it without any kind of hindrance. So this was all about our project, how we did it and the implementation part as well as the installation part, and this is how it operates even. So thank you. We hope this project would give you some kind of knowledge regarding electronics, regarding how things can be done in using LEDs and how a beautiful notice board can be prepared within a very few time. Thank you all. We would like to thank our guide, Professor Pratap Kumar Dakwa, Department of History, for showing his effort and support in completion of this project. We would also extend our heartfelt thanks to Professor Pravat Kumar Patnaik and Professor S.K. Pathar, who has coordinated the whole process and helped us in all the possible angles to go for the successful completion of this project. Special thanks to our HOD, Professor Sandeepan Pine, and Dean Ma'am, Professor Anita Pathar, who has helped us in all the ways to come up with this project and install it. And moreover, we are very indebted to Professor Durga Padi sir, who has supported us and helped us whenever we required and whenever we wanted to install it. He has always supported, extended his support. And finally, the friends, our group members and all those who have been directly or indirectly related to our project and has helped us in making this project successful. Thank you.